Okay. So for this to be an integer, and n is an integer, we need n in absolute value greater than 100 minus n in absolute value, just conceptually. I mean, we need 100 minus n to be a factor of n. I don't know how much that's going to come into effect. I mean, if I think of very large values of n, in fact, if n is I want to think about what happens around, like when n is approximately 100. If n is 101, like n equals 200 works. That's 200 divided by, does it say positive? No. 200 divided by negative 100, which is negative 2. But I think that's the largest value of n that will work, because this is getting larger and the denominator is getting larger in the negative direction. So, like, wait, hold on, what if... What if I go like n over 100 minus n is equal to negative 3? Is that possible? I might have just figured out a good way of solving this question. N equals 150. Yeah, that makes sense. Okay, so let's say n over 100 minus n is equal to an integer k. So I have n plus 1 times k is equal to 300k. Wait, what? I'm tired. N over 100 minus n is equal to k. So 100, oh my goodness, why 300? 100k minus nk. Oh my goodness, I am tired. This is n plus nk is equal to 100k. So I have n times k plus 1 is equal to 100k. So n is equal to 100 k over k plus 1. Okay. Okay. So I need k. K plus 1 is never a factor of k. Unless k is what, negative 2? I mean, and factor, we can allow these to be negative numbers, right? So I need k plus 1. Do I just need it to be a factor of 100? Is that the idea? I mean, we've already seen k equals -2. Check. If k is -3, what goes on here? 100 times -3 over -2. So that obviously divides that. N is 150. Can k and k plus 1 ever have prime factors in common? No. So if they had a prime factor in common, then k mod p is equal to 0, which is equal to k plus 1 mod p. And I have 1 is equal to 0 mod p. I should just know this, right? But it's been a long day. Okay. So I need either this to be an integer, which only happens when this is when the denominator is 1 or -1. So k equals 2, 1 works. K equals -1 works. No, it doesn't, sorry. K equals 0 works, in which case n is 0. Does k, it can't be -1, no, of course not. And then I just need to count all the factors of 100. Well, 100 is 2 times 5 squared. So how many factors are there? It's is it 9? But that includes a fact when this is equal to 1. So I'm double counting that one. Ooh, but I also have the negative values it could be, right? So and when k is equal to -2, that's equal to -1. So I'm going to ignore these cases. Imagine I have not counted them. Really what I need is I simply need the denominator to be a factor of 100, because this will capture the two cases where the denominator is plus or minus 1. Okay, so the number of factors of 100 is 9, number of positive factors. So if I include negative factors, this is 18 positive or negative factors. And I think that's it. So if p is a factor of 100, then let's let k plus 1 equal to p. Then n is equal to 100 times k over k plus 1. So n is 100 times p minus 1 over p. P is any factor of 100, positive or negative. So clearly if p is a factor of 100, then this is an integer. and that tells us what n is. So I get that it's 18. Assuming I counted the total number of factors right. 2 squared times 5 squared. So I have three possibilities of 2 and 3 possibilities of 5. That's 3 times 3, right? I mean, just count them. 1, 2, 4, 5, 10, 20, 25, 50, and 100. That's 9. Okay, yeah, I hope that's right. If I think of any mistakes on this one, I'll let you know. But I don't have solutions to this one, given that it was a viewer submission. It was a nice little problem. You got to think about it a little bit differently. But I guess the first thing that came to mind was not to simply solve for n, right? This is not the first thing that came to mind. But that came to mind, and it became, I don't want to say obvious, but it seemed pretty clear that this is going to be a good way to solve this question, but I didn't think of that until I just started sort of guessing and checking. And I said, can I find a value of n that makes this thing equal to -3? And then, once I've set up an equation, I can clearly solve for n. Well, I was like, well, let's do this for a general value of k. And then you get, the conditions that you need to be satisfied by k. Nice problem. Thanks for the submission, and thanks for watching.